Please look at the drawing of our sample parts. Operations to include in our program correspond with contour elements on our part. The list of all these operations you see on the right side of the drawing. Our task is to decide which of them should be executed in which channel, in channel 1 or channel 2, and also to determine the sequence of their execution in each channel. Also, you can notice here the symbol of part 0. It shows that we will start machining in main spindle from this side. The distance of pickoff is also given. It will be executed, as you see, at the diameter 9 at this section. We have to remember that we will work with guide bush on our DT26HP machine. It means that we have to observe the basic principle, which says that it is necessary for a bar to be supported during machining in guide bush collet. Here in this right drawing you see guide bush collet, and this section is especially important to us because at this distance a bar is supported. Normally this distance equals approximately collet diameter, this diameter. Let's analyze the case presented in this right drawing. Here we have a bar already turned at some distance, and later the not turned length is left. This situation is correct because you see that all the time the bar is supported here. But we can imagine also a situation like in this drawing. Here the length of turn diameter is longer and a bar is retracted in that way that collet doesn't support a bar. This is a wrong case. We have to avoid it. We should keep this principle of supporting of a bar in guide bush, especially with operations with multi-passes. When a bar diameter is already turned, it shouldn't be retracted to a position like shown in this drawing that it isn't supported in collet. Returning to our drawing of our part, please notice that we have here in main operation a long hole, and it will be drilled in many passes. During this operation, a bar all the time should be supported. It means that it is necessary first to machine this hole and only after it make external contour. But one remark: before we start machining of a hole, we will make facing first, not to have burrs inside. And of course, just after facing, we will make centering. We will use spotting tool to make here a chamfer. We need this chamfer to guide the drill and also for tapping operation. And centering will be followed by multipass drilling of diameter 3.5. We'll finish machining of this hole with tapping operation when an internal thread M4 will be done. Having the hole finished, we can deal with the external contour and turning it. First, please notice that our bar diameter is 12 and we have to turn it to diameter 9. We can make it in one pass without any retracting of a bar. That is why we can continue this turning till the end of the groove. And of course, grooving will be the next step. Within this operation, we will machine this round, groove, chamfer at the end and continue further. We have a radial hole of diameter 3 on a groove. To do it, we need rotating holders, we have them in main operation here. Drilling will be executed on cylindrical surface, not flat. That is why we will start first with centering. And of course, next step will be drilling, transversal drilling. The last operation to execute in channel 1 is cutoff. It will be done when we finish machining in main spindle. Let's now focus on back operation. We will start machining with this hole, and our first operation will be centering. Next step, surely drilling of diameter 4. And the last step will be internal turning. We will turn here this diameter 6 and also make flat step here. We will continue with turning of external contour, this one, but as first will be done facing and only after it external contour turning. We will finish our part with external threading executed in back operation. Let's focus now on tools layout. On this left side here, you see the list of all tools necessary to execute operations which we planned. And a short comment about those tables you see here. They correspond with supports on our machine in configuration as shown in this photo. So first we have stationary transversal tools in main operation. Below they are rotating tools, like here. In the middle, these 3 positions represent tools assembled on B-axis which work with main spindle. To the right, also tools which we can assemble on B-axis but working with back spindle. And the last table represents gang in back operation. Our task now is to assign each tool from this list to specific position on our machine. It is easy to assign cutoff tool because this tool has a fixed position on our DT26 HP machine. This is position T130. Please notice that when this tool is in the center of a bar, then this whole gang is retracted to the right. It makes free space for back spindle to approach safely for pickoff. The other stationary transversal tools, I mean front turning and grooving, to assign in channel 1, will work one after one. That is why we will place them on adjacent positions to minimize the time of tool change. Let us discuss now longitudinal tools assembled on B-axis to make a hole. Tapping tool should be placed on the top of B-axis because of better rigidity. And the other longitudinal tools, centering and drilling, should be placed in the order of their work. First will be centering tool, that is why it will be placed at the bottom, drilling tool in the middle, and as we said, tapping tool at the top. Transversal tools to make a radial hole can be placed only on rotary holders, so we can take 2 first positions to place them. First centering, after it drilling. And some words about the layout of tools in back operation. You see here that in our configuration of a machine we have 1 rotary holder in back operation on position T540. Centering tool will work as the first tool. That is why it is good choice to place it here. And the next two tools used to machine a hole in back operation will be placed according to the sequence of their work. So, drill of diameter 4 first, and on adjacent position, internal turning tool. At the end, we have to assign the last two tools to make external contour and external threading. First, let us discuss threading. This is multi-pass operation, and at the end of each pass there is retraction and return to the start point. In this case, it would be better to place this threading tool on the right outermost position, it means T511, to have enough space for back spindle to execute all these returns and passes. And in this situation, we have the only one free position for external turning. This is T510. So, all tools are layout, and now please notice that there is also the information about types of collates for driven tools. They are ESX20 and ESX12 for all tools assembled on B axis. The standard type of collet for main and back spindles is F30. And of course we will use this type of collet of diameter 9 for back spindle to execute pickoff and machining in channel 2.